Now that we've taken a look at some of the basics of creating mates, moving parts, and some of the fundamentals of creating assemblies, let's go through an exercise where we put together a simple assembly like this one here, and take a look at how to create motion. Let's start with a new assembly file, and bring in the first component. The part already exists, so I'll click Browse to browse to the location of the file. The first part I want to bring in is the base, so I'll select it, and click Open. When I drag the cursor into the graphics area, you can see the part's orientation doesn't match the orientation I want. This means I'll have to add mates between the parts planes and the assembly planes to ensure that the origin of the part and the assembly origin align. Before I place the component, let me rotate it to make adding mates later on easier. To do this, I'll go to the Property Manager, and under Options, enable the Rotate Context toolbar. When I drag the cursor into the graphics area, a pop-up menu appears, and I can use it to rotate the component in the X, Y, or Z directions. I can also right-click in the graphics area and select one of the rotate options. The orientation looks good, so I'll click the green check. Before I add the rest of the components, I want to make sure the origins are aligned. If I select the assembly origin and the base origin, you can see they're not aligned, so I'll have to add a couple of coincident mates between the part and assembly planes. Notice, if I try to move the component, a tooltip appears, letting me know that the component is fixed and cannot be moved. If I want to add mates using this component's planes, I first have to float it in the assembly. To do this, I'll right-click the component in the graphics area and select Float. Now, if I try to move the component, you can see it's free to move in any direction. To fully define the component, first I'll add a mate to the assembly front plane. From the feature tree, I'll select the front plane. While making sure to hold the Control key down, I'll expand the base component and hover the cursor over each of the planes until I see the one that's parallel to the front plane. In this case, the top plane. I'll select it. And when I release the Control key, the context toolbar appears with mates that are appropriate for the selection I made. I'll click Coincident, and the mate is added. I'll repeat this process for the other two planes. I'll Control select the assembly top plane and the component front plane. I'll release the Control key and add a coincident mate. Finally, I'll add a coincident mate between the assembly right plane and the component right plane. Now, if I select both the assembly origin and component origin, you can see they're aligned. With the first component in place, I'm ready to add the rest of the components. I'll click the Insert Components icon from the Command Manager, and I'll pin the Property Manager so I can bring in all the components in the same step. I'll browse to the same location as before, and I'll select the rest of the parts. I'll click Open, and you can see they're all listed in the Property Manager. I'll insert one instance of each part. And click the green check. Before I add the mates, I'll make sure the document units are set to MMGS. The first mate I'll create is between the pin and the hole in the cylinder. I'll Control select the pin's cylindrical face and one of the cylindrical faces of the cutout, and from the context toolbar, I'll select Concentric. To center the pin in the cylinder, I'll add another mate between one of the pin's end faces and the cylinder's outer face. From the context toolbar, I'll select Concentric, and the pin is mated. Next, I'll mate the cylinder to the base. I'll select the two cylindrical faces and add a concentric mate. Next, I'll align the arm. First, I'll add a concentric mate between the arm's cylindrical face and the circular face of the base component. To position the arm, next I'll add a distance mate between this face of the arm and the inner face of the base. I'll type in a distance of 37.5 millimeters and click the green check. All that's left to do is position the link component. To save myself some time, I'll use a smart mate to position the link within the arm. I'll select one of the link's circular edges, and while holding down the Alt key, I'll drag it to the arm. When the preview looks good, I'll release the mouse, and the link is perfectly positioned within the arm. To finish it off, I'll add a concentric mate between the other link hole and the pin in the cylinder. I'll select them, select concentric, and the assembly is complete. With the last mate I added, you can see the only motion left is the motion I was looking for from the beginning. In this exercise, we're going to take a look at how to put together an assembly using subassemblies. Let's start with a new assembly and bring in our first subassembly. We're looking for an assembly, so we'll change the Files of Type dropdown to look for assembly files. And now, we are only looking at assemblies. The assembly I'm looking for is the boom assembly. I'll drop the assembly on the origin to locate it in the assembly. And there, I have my first subassembly in this top-level assembly. So the thing to notice here is there is no special file type or process for defining a subassembly. A subassembly is simply an assembly that has been inserted into another assembly. If you look at the Feature Manager tree, you can see that the icon for the subassembly is the same as the icon for any assembly. If I click the arrow sign, you can see the components that make up that subassembly. I'll continue with the next subassembly, called Swivel Brace. Positioning subassemblies is no different than positioning individual parts. I use regular mates, and the subassembly behaves just as a part would. Next, I'll bring in the fastener subassembly. This is fairly common, where a fastener is pre-assembled with a washer or nut. You can save time by bringing the two parts together in an assembly and then using smart mates for positioning. If for any reason the fastener comes in upside down, I can press the Tab key on the keyboard to flip the fastener. I need one more set of these fasteners. I can create a copy by pressing the Control key on my keyboard while dragging the assembly in from the Feature Manager tree. After I let go with my cursor, you can see a copy of the subassembly has appeared in the graphics window and also in the feature tree. A number 2 in brackets next to the parts tells me that this is the second instance of the subassembly in the assembly. One more smart mate, and the fasteners are located. To finish up the assembly, I'll bring in a couple of nuts. These are parts, so I have to change the Files of Type back to part. I can use smart mates again for positioning, and I'll repeat the process one more time on the other side. So that's all there is to using subassemblies. For the most part, there is nothing different between working with parts and working with subassemblies, except when it comes to motion. By default, subassemblies will behave as if they are rigid parts. You can see that when I move the brace, it only spins here at the swivel. However, if I open the swivel brace assembly by itself, you can see that the brace should also pivot. You have to take an extra step in order for assemblies to behave like flexible mechanisms when they are used as subassemblies. What you have to do is click on the assembly in the Feature Manager, and from the pop-up, select Make Subassembly Flexible. Watch now how the brace pivots the way you would expect. In this exercise, we're going to take a look at how to create subassemblies and how to insert them into the main assembly using this model. As you can see, this scissor jack was created using both parts and subassemblies. Notice in the Feature Manager design tree that the same arm length subassembly was used twice, and the screw subassembly once. And if I move the assembly, you can see the jack moves as expected. The arms are free to move up and down, and the screw and top bracket remain horizontal. To create this model, I'll start by creating the arm length subassembly first. Recall that a subassembly is simply an assembly that you insert into an existing assembly, so I'll start a new assembly file. Before I insert a part, let me pin the property manager. The arm link subassembly contains 3 part files: the upper arm, lower arm, and pin. I'll browse for the 3 items and click Open. The first component I'll place is the pin. I'll select it. And notice the part orientation doesn't match the assembly orientation I want. I'll rotate it once in the Y direction by right-clicking in the graphics area and selecting Rotate Y 90 degrees, and once in the Z direction by selecting Rotate Z 90 degrees. And click the green check to place it on the assembly origin. Next, I'll add 1 instance of the upper arm link and 1 instance of the lower arm link. First, I'll mate the lower arm component. I'll add a concentric mate between one of the faces on this end of the arm and the pin. I'll Control-select the faces, and from the context toolbar, I'll click concentric. Next, I'll add a coincident mate between the outer face of the arm and this inner face of the pin. I'll drag the arm, and you can see it's only free to rotate about the pin. This is the motion I'm looking for, so I'll mate the upper arm component next. Before I add the first mate, let me rotate the upper arm component to get the right orientation. I'll use the right mouse button to get it to the position I want. The upper arm looks good, so I'll add the mates. First, I'll add a concentric mate between this end of the upper arm and the pin, just as before. Next, I'll add a coincident mate between the outer face of the upper arm and the inner face of the lower arm. If I drag the upper arm, you can see it's free to rotate about the pin. With the subassembly complete, I'll go ahead and save it. I'll make sure to browse to the correct folder, and I'll name it Arm-Link Subassembly. And click Save. For the main assembly, I'll be using 2 instances of this model, so I'll move on to create the screw subassembly. I'll start a new assembly file, pin the property manager, and browse for the part files. I'll select both the screw and pin-handle. First, I'll select the screw and click the green check to place it on the origin. Next, I'll place the pin and click the green check to exit. First, I'll position the pin within the hole in the screw. I'll select the 2 circular faces, and from the context menu, I'll click concentric. Next, to center the pin and screw, I'll add coincident mates between their planes. In the feature tree, I'll expand each of the component folders, and I'll select the screw front plane and the pin front plane. I'll add a coincident mate, and the subassembly is complete. I'll save this assembly in the same folder that I saved the previous assembly. I'll give it the name Screw Subassembly, and click Save. With the subassemblies complete, I'm ready to create the scissor jack assembly. At this point, I've created the 2 subassemblies that I need to build the scissor jack assembly, and I have all the part files I need. I'll start by creating a new assembly. And I'll pin the property manager once again. Since I have both the subassemblies open, you can see they appear under the Part Assembly to Insert group box. However, the first component that I want to place is the foot, so I'll browse for it and click the green check to place it on the assembly origin. Before I bring in all of the components I need, I want to position the subassemblies I just created. I'll insert 1 instance of the screw subassembly and 2 instances of the arm link subassembly. To make positioning the second arm link subassembly easier, I'll rotate it to 180 degrees in the Y direction using the rotate toolbar. To exit, I'll click the green check. First, I'll position the arms. I'll add a concentric mate between the cutouts on the foot and lower arm, and a coincident mate between the outer face of the lower arm and inner face of the foot. I'll add the same mates between the foot and the other arm link subassembly. Next, I'll position the screw subassembly. This time, I'll use smart mates to position the screw in the right arm link subassembly. I'll select this edge, and while holding down the Alt key, I'll drag it to the circular edge of the pinhole. The feedback next to my cursor shows that a concentric and coincident mate will be created, so I'll release the component. Next, I'll add a concentric mate between the screw subassembly and the other arm link subassembly. I'll select the two circular faces and select concentric. Before I continue, I want to point out that the way the assembly is mated, it's causing an interference between the two upper arm components. However, if I try to move it, you can see a tooltip appears letting me know that the component is fully defined. In the feature tree, notice the assembly icon next to each of the arm link subassemblies lets me know that they are rigid. To make them flexible, I'll click on the subassembly name, and from the context toolbar, I'll click the Make Subassembly Flexible icon. You can see the assembly icon updates to indicate the subassembly is flexible. And if I drag the arms, you can see they're free to rotate. However, you can see the screw assembly doesn't remain horizontal. To fix this, I'll add a parallel mate between the assembly top plane and the screw subassembly top plane. If I move the arms now, you can see the screw remains horizontal. With the subassemblies in position, I'll add the remaining components. From the Assembly tab of the Command Manager, I'll click Insert Components. Next, I'll browse to the parts. Pin large, pin small, and top bracket. And select the push pin to make sure the Property Manager stays pinned. If not, then the Property Manager will close after you insert the first component. I'll insert 2 instances of each pin. And 1 of the bracket. I'll click OK. First, I'll position the top bracket. I'll add 2 concentric mates, one between the bracket and right upper arm component, and the other between the bracket and left upper arm component. Next, I'll add a coincident mate between the outer face of one of the arms and the inner face of the bracket. If I move the bracket, you can see it doesn't remain in a horizontal position, so I'll add 1 more mate between the top face of the bracket and the assembly top plane. I'll select Parallel, and now the top bracket moves as expected. To finish the assembly, I'll add a couple of smart mates to position the pins. I'll mate the smaller pins to the top bracket and the larger pins to the foot. You can see the assembly moves as expected.